Okay, so today we are going to carry on with geometric sequences and other non-linear sequences. Our learning objective will be to be able to find the next two terms in a geometric sequence and also to recognize other non-linear sequences. So just a little recap from last lesson where we were finding the common difference in linear sequences. Linear sequences are sequences that go up or down by the same amount each time. So if we look at the example, the first example, we've got 5, 8, 11, 14, 17. Each term is going up by 3. Okay, so our rule is add 3, and in order to find the next two terms, we would simply add 3 onto 17 and so forth. Pause the video and give these a go. Answers are on the next slide. Okay, make sure to mark your work, and if you've made a mistake, have a little think about where you went wrong. So here's an example of a very famous sequence. Some of you might already recognize it. And if you have a little look at the sequence we've got here, we've got 0, 1, 1, 2, 3, and so forth. Pause the video and see if you can find the next 3 terms of the sequence. Can you figure out what the rule is? Okay, so I hope you noticed what the rule was, and some of you, like I said, might recognize it. This is a very famous sequence, and if you look at the terms, I will see if I can have. Okay, so if you have a look, 0 and 1, if you add those together, you will get 1. Okay, if you add 1 and 1 together, you will get this 2. If you add the 1 and the 2, you will get this 3. If you add this 2 and this 3, you will get the 5. So each term is made up by adding the 2 terms in front of it. So this 8 is made up by adding 3 and 5. Okay, so we can very easily see that we can, let's rub this out, find the next few terms in the sequence simply by adding these two together. Okay, so our next term would be 13. And then if you add 13 and 8, you'd get 21. There is a really interesting little diagram over here of the sequence. It kind of makes a spiral, and it is called the Fibonacci sequence. Okay, so here we've got another Fibonacci spiral. Okay, if you remember what the sequence looked like, we started off with 0, then we had 1, then we had another 1, then we had a 2, then we had a 3, and then we had 5, then we had 8, 13, and 21. So how it was made, 0 and 1 would give us the 1. The 2 plus the 1 would give us the 3 and the 2 would give us the 5. And if they are represented as squares, you could draw the sequence to represent a spiral, which is in fact represented throughout nature. So here we've got the spiral represented in nature and even in cauliflower. Okay, so here is another example of a non-linear sequence. I would like you to pause the video and see if you can figure out what the next picture is going to look like and how many dots will be in that next picture in the sequence. Okay, so let's have a look at what you might have noticed. One way to look at it to start off with is to compare what is staying the same and what is different in each consecutive number. if you have a look at the 3 over here, okay, we can see that in addition to the one that we started with, we added 2 there. In the next term, we can see that in addition to the 3 we had in the previous term, we had added another 3. If we look at the 4th term, we can see that we added 4 extra little dots in that row. So from that we can conclude that in our 5th term, in our 5th picture, we are going to be probably adding 5. Okay, so let's test that. If I'm going to form another little row at the bottom, and then add an extra 1, and that is 5. So our next term would in fact be 15. Okay, and also, what do you think the sequence might be called? Okay, these numbers 1, 3, 6, 10, and 15 have got a special name, and in fact they are called triangular numbers because have a look, you can form a triangle. Okay, from the pictures. So these are called triangular numbers. Okay, so here is another non-linear sequence, but these are numbers really that we are more familiar with. Can you please pause the video now and see if you can figure out how many squares are going to be in the next picture? Okay, so I'm hoping that you notice that here we've got our square numbers, okay, because we can see 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. So our next term in the sequence is going to be 25, because 5 squared, or 5 times 5, is going to give us 25. So this is a sequence of our square numbers. And the reason we call them square numbers is because we can rearrange the squares into squares. Okay, so what is the next term in this sequence? Pause the video and see if you can figure out how many squares are going to be in the next picture. Okay, so I hope you recognized this sequence as a linear sequence, because if you can have a look, each time from term to term, from picture to picture, we are going up by 2 each time. We are adding a square at both ends, so we are adding 2 squares each time. So our sequence is going up in 2 from term to term, and any number that is going up by a common difference or down is called a linear sequence. So this is just a picture version of the sequences we did in our last lesson. Now this is the sequence that we're going to really focus on today. Okay, and let's see if you can figure out what is happening here. Okay, so we start with 3 dots. Next one, we have 9 dots. Next one, we have 27 dots. Next one, we have 81. And the next one, we got 243. Pause the video and see if you can find a relationship between the numbers. Okay. Okay, pause your video now. Okay, so having a look at this, what is the relationship between each one of these numbers? Well, I've got 3 over there, and then look, I've got 3, lots of 3 there. Okay, that's 9. I wonder how many is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 3 lots of 9 in 27. Okay, and you will find that each term is a multiple, is multiplied by 3. Okay, multiplied by 3. Okay, I do wish this would write nicer, but you get the general idea. So from term to term, okay, we are multiplying by 3. Okay, so 3 times 3 is 9, 9 times 3 is 27, 27 times by 3 is going to be 81, and 3 times 81 is 247. Okay, and 247 multiplied by 3 is going to give us 729. So we are moving from term to term by multiplying by 3. So each term in the sequence is 3 times the term before it, and that is called a geometric sequence. So a geometric sequence is one where we get from one term to the next by multiplying by the same value. This is called a common ratio. So I would like you to be able to write this into your book. So important, we are multiplying this time, okay, and it's called a common ratio. So if we look at this sequence, we've got 1, 2, 4, 8, 16, and we can see that each term is doubled. Okay, so 1 times by 2 is 2, 2 times by 2 is 4, 4 times by 2 is 8. So each time we are multiplying by the same number, and that number, that value, is called a common ratio. Okay, so your activity today is to fill in the worksheet that is attached in Classcharts. You don't have to download the worksheet because all the questions are, in fact, in this video. Just pause while working through the question. This question, question number 1, says which of the following sequences are geometric. So you need to figure out which one of these sequences can be created by multiplying by the same amount each time. If you have a look at the first question, I'm going from 1 to 3 to 9 to 27. You would be ticking that because that is a geometric sequence. It is the same one that we've had in our example. You're multiplying each term by 3 to get to the next term. The other thing you need to do is fill in the missing words up there. So a sequence is geometric if it has A, and the answer was on the previous slide. See if you can remember it. Question 2, these are now geometric sequences, we are told that, and you need to find out how you're getting from one term to the next. The easiest way to find what that rule is to take our two consecutive terms. So for example, in A, okay, you would take, let's say these two, they are consecutive terms because they're next to each other. If you divide it by 4 by 2, you get 2. That number is our common ratio. If you have a look, and in fact, if you divide 8 by 4, you get 2 again. So each time we are timesing by 2 in order to get the next term. That's a good way to find your common ratio. So work through these, okay, and there will be an answer sheet attached in Classcharts, okay. Answers are not in this video. Okay, so question 3 on the worksheet says generate the first 4 terms of the sequence described below. So what they are saying is that we need to write the first 4 numbers in the sequence. They've already started us off. They've put it into a nice little table here. These numbers at the top, this 1 and this 2, okay, these are the terms in the sequence. So what they're saying is that that 1 is the one in the sequence. The second number or the second term in the sequence is 10. The third term in the sequence is the one we need to fill in and we need to find out. So they've said the rule is 1 times by 10 is going to give us 10, and so we need to multiply 10 by 10 in order to find this missing term, and that's how the rest of these work. In B, they have given us 2 numbers. We need to find the missing 2. In C, they say start with 4 and multiply by 6 every time. So in fact, they're telling you what the answer is there. Okay, because it says start with 4. So this number is in fact going to be 4. and 4 times by 6 is indeed 24, and then we need to multiply by 6 in order to find the next terms. Okay, give these a go and mark your answers using the answer sheet that is attached in Classcharts.